Please like and subscribe our channel and press the bell icon.
Today we will discuss integers. We discuss what is integers, what are the properties of integers. And integers is a positive or negative number with no fractional parts. 0 is also integers. It means it have no fractional parts such as 1 by 2, 1 by 4. There is no fractional part in integers numbers. For example, -4, +4, -5, +5, etc. etc. There are some properties of the integers such as closure property, distributive property, commutative property, identity property, associative property, and inverse property. We will discuss one by one. First, we discuss closure property under subtraction and addition. It states that the sum or difference of any two integers will always be an integers. That is, if x and y are any two integers, x plus y and x minus y will also be an integers. It means that if we minus or plus any two integers, its results will be an integers. For example, if we 3 minus 4, so answer equal -1. And if we minus 5 plus 8, if we in the second example we add two integers, answer equal to 3. And in the first example we subtract two integers, the result is also integers. Therefore the results are as integers. Property is valid under subtraction and addition. We observe that closure property under addition and subtraction are valid. Now we see closure property under multiplication and division. Closure property of multiplication states that product of any two integers will be an integers. That is, if x and y are any two integers, x into y will also be an integers. For example, 6 into 9 equal to 54. 6 is an integers, 9 is also integers, and 54 is also an integers. -5 into 3. -5 is an integer, 3 is an also integer equal to -15, which are integers. We can see in the case of multiplication, closure property is valid. Therefore, we see division of integers. Division of integers does not follow the closure property. That is, a question of any two integers x and y may or may not be an integers. If we divide two numbers, sometimes it is not be a integers. For example, if we divide 3 by 6, then we see we get 1 by 2, which is a fraction. Therefore, in the case of division, closure property is not valid. But in the case of multiplication, addition and subtraction, closure property are valid. Therefore, the closure property are valid in the case of multiplication, division and subtraction for integers. Next, we discuss commutative property. The commutative property of addition and multiplication states that the order of terms does not matter. The result will be the same, whether it is addition or multiplication. Swapping of terms will not change the product or sum. Suppose x and y are any two integers, then x plus y equal to y plus x. It means in first case, if we add two integers, and in second case, if we add the same integers, but in the second case we interchange the terms, then in the two cases the result will be the same. For example, if we add 4 and -6, we get -2, and if we add -6 and 4, then the result is also -2. Therefore, commutative property is valid under addition. If we see in the case of multiplication, we get x into y equal to y into x. That is the same case if we multiply two integers, and if we multiply the same integers but we interchange the terms, now the result in the two cases will be same. If we multiply 4 into -6, the result is -24. If we interchange the term and multiply -6 into 4, the result is also -24. Therefore, under multiplication, the commutative property is valid. If we check in the case of subtraction and division, we get subtraction and division are not commutative for integers, because if we subtract two integers, it is not equal to the numbers if we interchange the numbers and subtract. For example, we see 4 minus of minus 6. We subtract 4 and minus 6, we get 10. And if we subtract minus 6 and 4, we get minus 10. Therefore, it is not equal to the 10 and minus 10. If we check in the case of division, we also get the same result. If we divide 8 by 4, we get 2, and if we interchange the number and divide 4 by 8, we get half. Therefore, in the case of subtraction and division, commutative property is not valid. Next, we will discuss associative properties. First, we check associative property under addition and multiplication. The associative property of addition and multiplication states that the way of grouping of numbers does not matter. The result will be the same. One can group numbers in any way, but the answer will remain same. For example, let x, y, z be three integers, then x plus y plus z. In left hand side, we group y plus z, and in right hand side, x plus y plus z, we group x and y. Therefore, it does not matter in which way the number is grouped. The result will be the same. In left hand side, the answer is equal to the in the right hand side. Therefore, in the case of addition, the associative property is valid. In the same case, in multiplication, while multiplication x into y into z, in left hand side we group y and z, and in right hand side we group x and y. Therefore, the result will be same. It does not matter in which way the number is grouped. Therefore, associative property under addition and multiplications are valid. For example, if we take 1, 2 and 3, first we add 1 and group the numbers 2 and minus 3. The answer should be 0, and in the right hand side we group 1 and 2 plus minus 3. The answer is equal to 0. If we take examples in case of multiplication, we get first we write 1 and 1 into, and we group 2 and minus 3. The answer is minus 6. And next we group 1 and 2, and the answer should be minus 6. Therefore, right hand side is equal to left hand side. Therefore, addition and multiplications, the commutative properties are valid. Next, we check subtraction and division. Subtraction of integers is not associative in nature, as well as division of integers is not associative in nature, as the right hand side is not equal to left hand side. Next, we will discuss distributive property. The distributing property explains the distributing ability of a operation over another mathematical operation within a bracket. It can be either distributive property of multiplication over addition or distributive property of multiplication over subtraction. Here, integers are added or subtracted first and then multiply first with each number within the bracket and then added or subtracted. We understand well if we take the formula of distributing property of multiplication over addition and distributing property of multiplication over subtraction. First, we see the distributive property of multiplication over addition. A within bracket b plus c equal to a multiply with first term ab plus multiply with second term ac. Next, we see the formula that distributive property of multiplication over subtraction. We see a into within bracket b minus c equal to a into first term minus a into second term, where a, b and c are integers. Next, we see examples. In the first examples, we see distributive property of multiplication over addition. The first example is 2 multiply within bracket minus 3 plus 4 equal to 2 multiply minus 3 plus 2 multiply 4. That is 2 multiply first term plus 2 multiply second term. And we check RHS equal to LHS. If the results of the left hand side is equal to results of the right hand side, then we can say that the distributive property of multiplication over additions is valid. We check in left hand side 2 within bracket minus 3 plus 4. We first add and multiply, then within bracket we get minus 3 plus 4 1 and multiply, that is 2. And in right hand side we first multiply and add, and 2 into first term plus 2 into second term, therefore minus 6 plus 8 equal to 2. Therefore LHS equal to RHS. Therefore we can say that distributive property of multiplication over addition is valid. In the second example, it is the distributive property of multiplication over subtraction. We take as same examples, but the sign is minus. Therefore 2 into minus 3 minus 4 equal to 2 into first term into 2 into second term, that is 2 into minus 3 minus 2 into minus 4. Again we check left hand side equal to RHS, then we say that distributive property of multiplication over subtraction is valid. In left hand side we first subtract and multiply, then we get within the bracket minus 7 and 2 into minus 7 equal to minus 14, and in right hand side we multiplied and subtract. Therefore the answer is minus 6 minus 6, therefore the answer is minus 14. Therefore RHS equal to LHS. Therefore we can say that distributive property of multiplication over subtraction is valid, and distributive property of multiplication over addition or subtraction are valid. Next we discuss identity property. There are two identity, one is additive identity and two is multiplicative identity. In additive identity states that the sum of any integers and 0 is a given number. For example, 5 plus 0 equal to 5. Therefore 0 is the additive identity. Sum of any integers and 0 is equal to the given number. Therefore 0 is the additive identity. In multiplicative identity states that multiplication of any integers and 1 is the given number. Therefore, for example, 5 ones are 5, minus 3 ones are minus 3, minus 4 ones are minus 4. Therefore, any integers which we multiplied by 1, the answer is the same number or given number. Therefore 1 is the multiplicative identity. Now we will discuss the last properties of integers. This property is inverse property. It is the additive inverse and multiplicative inverse. In additive inverse states that it simply tells us to simply take a number and add its opposite, so we get 0. For example, if we take 6 and its opposite is minus 6, therefore plus and minus, the result is minus, therefore 6 minus 6 equal to 0. In additive inverse the result is 0. Therefore if we add an integers, we add them its opposite, so we get 0. Therefore it is the additive inverse. And multiplicative inverse, it simply tells us to simply take an integers and multiply its reciprocal to get 1. For example, if we take 6 and its reciprocal is 1 by 6, therefore the result is 1. The properties of integers are discussed and the chapters integers are discussed. For latest update of such videos, please subscribe our channel. Don't forget to like, comment and share. It encourages us to make such videos. Thank you.